Hi again. So we have reached exercise 11, which is a UVA question, so about mice and mazes. So briefly, we have a maze and we have multiple mice, and they need to get out of the maze. So the maze consists of cells, of many cells. For example, here we have an example for cells. So n is the total number of cells, and then we have e, the number of exit cells. So we have 2 exit cells and 1 is a timer, and we need to know how many mice can get out of the maze within this time. So we have also then a set of connections, so how the passages from one cell to a cell and how much it costs. So we need to know the number of mice that can get out in a T unit. So it's a very easy exercise. So it's a shortest path. So we need to do the extra since all the weights are positive, and in the extra we need to check at the end for each vertex the distance. So if distance is less or equal than 1, then the time limit, so the mouse could get out, otherwise it will be not the case. So let's start. So in the extra we will be using a priority queue. So I have kept the priority queue. However, in this solution, since it's a UVA, I will not bother myself with the implementation of a graph. I will directly use just a double array, an adjacency matrix in the solution. So in the main, I have read the number of test cases and launched the test function. So in test, I will do all the stuff. I will read the 4 values here, and so 4 is the number of cells of mice, to the number of 4 is the number of cells, 2 is the number of exit mazes, and 1 is the time, and 8 is the number of connections, and then we should output that. So I will read all these in the function. So I'll start with scanning. I'll scan 4 integers. So the first one, I will call it n. This is the number of cells. D, the exit cells, and TLE. So we will start from D since we need to know the exit cells, and then M, the number of connections. So I will add these here, int N, D, TLE, and M. And then I need to read the M connections, the N edges. So I need an adjacency matrix. So int, and I will start to read. So edge equal int star star malloc size of int star. So we need to count. So here what I will do is that since the numbers of cells are from 1, I will reserve n plus 1 cell. So I will drop index 0 when traversing the adjacency and all the graph. So, and then I need to initialize the, so I need to also, so I need a counter here for the loop. So I'll start from 1 and include it till n, I plus plus. So edge of I is equal to that. So at the same time, I will do initialize the distance array. So I need a distance. So distance of I would be equal to -1, and of course I need to declare it above. So distance So I have declared a constant above, which is v equal to 101. It's in the text of the UVA. So then I will need to read all the connections, the M connections. So I equals 0, I less than M, I plus plus, and I need to scan F, X, Y, and W. So I need X, Y, and W, X, Y, and W. So I'll do scan F 3%D, X, Y, and W, and then I need to add it to the adjacency matrix, and it's a directed one. So adjacency of X, Y is equal to W, and then we need to move to the extra. So we need a Q. and we need to add the starting vertex and the distance, so we'll in q, so address of q. So we're starting from d, from the exit, and we are, so d and the distance d equal to 0, and we'll place the distance of d is equal to 0. So and then we will loop over the q as long as we have a front. So q address of v, so we need an element v, so it's an integer. Let's place it here. We dq the element, and we will loop over its adjacent vertices and check. So for you have I, so I equal to 1, I less than or equal to n, I plus plus. So if the adjacency matrix of vi is different than 0, so we'll calculate the distance. So this, we need this, so distance would be equal to distance of v plus edge of vi, and then we need to check. So if distance of I is equal to minus 1, so if there is no distance, I will update the distance. So distance of I would be equal to this, and of course we will enqueue the element I with the priority distance. Otherwise, so if the newly distance is less than, so if distance is less than distance of I, it means if distance of I is greater than distance, I will update those stuff. So I will copy this, I will say distance of I equal distance, and I will update the priority. So the priority of q of I would be equal to distance. So, and this is it for the extra. And then I need to display the number, so I need to loop over the distance table in order to check whose distance is less than or equal to time limit, to TLE. So let's declare answer, so it's the number, so we'll start answer equal to 0, and we will loop for I equal 1, I less than or equal to n, I plus plus. So if the distance of I is less or equal to TLE, I will increment answer, and I will print f after for loop the answer percentage d backslash n answer. So I have here the input, so the output should be equal to 3. So we have just an error here, so there's a semicolon missing, and yes, you have ended with 3. So the solution is very easy, just to take the extra without the need of the path. So we didn't declare the path because we don't need the path array, and we just looped over the graph normally, but we have started from the end and we have continued backward till we see how many distances would be equal, less or equal to the time limit. So this is for this exercise. If you have any questions, do not hesitate to drop me a message and I will answer you back. And again, thanks for watching.